Hello students, welcome back to geometry. Today we're going to be talking about special right triangles. When we say special right triangles, we're talking about two very specific triangles. These are triangles that tend to occur in the natural world a lot. So basically, we've devoted some time to studying these specific shapes. So in order to understand the first one, I'm going to go ahead and draw a square. Okay, so squares are shapes that we see a lot. It's a four-sided figure, four right angles, and all of the sides are congruent. So I know that each of these angles is 90 degrees. So what I'm going to do here is let's assume that each side of this square is 1. If I draw the diagonal here to create a triangle, I get a right triangle, and I'm going to move this over here. And this is our first special right triangle. So I've got 1, 1, there's 90 degrees, and then these two angles right here got split in half, giving me two 45-degree angles, which leads us to the naming of this triangle. Since there is a 90-degree angle and then two 45-degree angles, the first special right triangle that we talk about is the 45-45-90 triangle. Now, we know that each of these sides is 1, but now I need to figure out what the hypotenuse is. So we're going to go ahead and use the Pythagorean theorem. A squared plus b squared is equal to c squared. In this case, 1 squared plus 1 squared equals c squared. Of course, 1 squared is just 1, because 1 times 1 is 1. 1 plus 1 is 2 equals c squared. Then we would take the square root of each side to get c is equal to the square root of 2. Now, the idea behind these similar right triangles, these special right triangles, is that all 45-45-90 triangles are similar to any other 45-45-90 triangle. So that means that if I have another 45-45-90 triangle, let's make this one bigger and pretend this isn't here. Okay, if this is 45 and this is 45, let's say, for example, that I know that this side right here is 12. Well, if one of the legs is 12, I know that the other leg is 12, and then looking over here at the green triangle, it goes 1, 1, square root of 2, so this would be 12, 12, 12 times the square root of 2. Okay, but what if it went backwards? What if I had this red triangle right here, and I knew that this piece right here were 5? If the hypotenuse is 5, well, in order to get from the leg to the hypotenuse, you multiply by the square root of 2. So in order to get from the hypotenuse to a leg, we would use the inverse operation, which would be to divide by the square root of 2. So that means if this is 5, that means this piece right here would be 5 divided by the square root of 2. Now, real quick, we're not allowed to end our answers with radicals in the denominator, so we have to do a quick little thing called rationalization. So if I have, I'm going to write this out a little nicer, 5 over the square root of 2, in order to make it so there's no radical in the denominator, I'm going to multiply it by the square root of 2, because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. However, since it's a fraction, if I multiply something to the denominator, I have to multiply it times the numerator to keep it a proper fraction. So 5 times the square root of 2 is just that, 5 square root of 2. Square root of 2 times the square root of 2 is the square root of 4, but we know that the square root of 4 is 2, so I get 5 square root of 2 over 2, and that's that. So I know that this is 5 square root of 2 over 2, and since these two sides match, this side has to be 5 square root of 2 over 2 as well. So let's do some examples. Oh look, 5 square root of 2. Where have I seen that before? Okay, so in this first one, I see that this is a 45 and a 90, so that means this last one has to be 45. The 8 is one of the legs, and I know that the legs match, so if this is 8, this is 8, and then this one must be 8 square root of 2. Now in part B, the 5 square root of 2 is on the hypotenuse, so that means if this is 5 square root of 2, I would divide by square root of 2, which would just get me 5. And then since the legs match, this one is also 5. So this brings us to our second special right triangle. And in order to do that, I'm going to draw a non-right triangle. But maybe let's do this. Uh-oh. Okay, we're gonna have to go fast. Oh, it's heartbreaking. There we go. So, just for the sake of argument and also because my battery's dying, I'm going to say that this is an equilateral triangle and each of these sides is 2. So, if I have an equilateral triangle, it's also equiangular, which means that each of these angles is 60 degrees. So, if I cut this triangle in half straight down the middle, I get this triangle right here, where this angle hasn't been touched, so this would be 60. The hypotenuse is still 2. The base got cut in half, so that's a 1. And then this top angle right here got cut in half, so that would be 30. Now, I need to figure out what this other side right here is. So that means that I would use the Pythagorean theorem again. A squared plus b squared is equal to c squared. And then we would say 1 squared plus b squared is equal to c squared is 2. So 2 squared. So now I've got 1 plus b squared is equal to 4. Subtracting 1 on both sides, I would get b squared equals 3. So therefore, b is equal to the square root of 3. Now, you can probably guess what this one is called. This is a 30, 60, 90 triangle. So in a 30, 60, 90 triangle, we still have 2 different legs, but this time we have the short leg, we have the long leg, and then we have the hypotenuse. Now, if we start with the short leg, the hypotenuse is always twice as big as the short leg. And if we start with the short leg, the long leg is always the short leg times the square root of 3. So, let's just go straight into some examples on how to use that. Okay, so in this case, I'm looking at number 3. I know this is the short leg, this is the long leg, and this is the hypotenuse. So I'm just going to draw my 30, 60, 90 triangle down here so I can remember. Here's 60, here's 30. If the short leg is 1, the hypotenuse is 2, and the long leg is the square root of 3. So, if the short leg is square root of 3, in order for me to figure out the long leg, I have to multiply times the square root of 3. So that means this side right here would be the square root of 3 times the square root of 3 is the square root of 9, which is 3. Now they didn't ask, but let's go ahead and figure out the hypotenuse too. So if I know what the short side is 1. To get to the hypotenuse, I just multiply by 2. So 2 times the square root of 3 is just 2 times the square root of 3. Now, on this other side, It didn't actually tell me that this is a 30, 60, 90 triangle, but what I do see is that each of the sides here is 4. I've got 4, 4, and then this piece altogether is 4, which means it's an equilateral triangle that just got cut in half. So that means this is 60 degrees and this is 30, so I can use my 30, 60, 90 triangle. In this case, I've got the short side. I already see that the hypotenuse is twice as big as the short side, so I just need to figure out the longer side. So if this is 2, going from the shorter side to the longer side, I'm just going to multiply that by the square root of 3, which gives me h is equal to 2 times the square root of 3. That's it. We're done.